This video lesson demonstrates how to solve real-world problems using systems of equations. This is designed to go along with your homework found on Moodle, Real-World Worksheet. Remember, during the week you were introduced to 3 different types of methods on how to solve systems of equations. The first method was equality. This method required you to put both equations in slope-intercept form, y equals mx plus b, and then set the 2 equations equal to each other and solve from there. Our second method is substitution. This method requires you to isolate the value of one of your variables to itself and then plug that in the other equation and solve from there. And our third method is combination, sometimes referred to as elimination. This method requires you to convert both equations into standard form, ax plus by equals c. That way you can combine the equations, thus eliminating one of the variables and solving from there. As we go through the worksheet, I'm just going to go through problem number 1, and you can choose which method works for you on your assignment, and we're going to discuss what strategy or what method works best given problem number 1. So please turn to problem number 1 in your Moodle Real World Worksheet. Problem 1. Mike counts out 61 in $1 and $5 bills. He has 17 bills in all. How many $1 and $5 bills does he have? First, we need to determine the 2 equations given to us in this problem. This first part of the problem tells us that the total value in all is $61. I'm going to let X stand for the $1 bills and Y stand for the $5 bills. So I know that however many $1 bills, however many X's, and however many $5 bills, however many Y's, add up to $61. So I'm going to replace this value up here into the equation. And I chose not to put 1 as my coefficient of x. I can just leave that value of x there without the coefficient of 1. But you can see that that many $1 bills plus that many $5 bills equals the value of $61. The second part of my problem tells me that I have 17 bills in all. That means my $1 bills and my $5 bills added together means I have a total of 17 individual dollar bills. That is represented by the equation 17 equals x plus y. Now I'm ready to put these in a system and determine which method is best to solve this problem. My system would look like this, and now I'm ready to solve. I'm looking at this and I see that they're lined up in standard form. So the easiest method that I see that would work is combination. I chose this because I see that this x and this x have the same coefficient of 1. I just need to make one the opposite. I need to make one of those x's negative x. So to do that, I'm going to multiply one of my equations by -1. When I do this, my new system looks like this. And now I'm going to start solving. 61 minus 17, 44. My x's cancel out. In other words, my x's are eliminated, and 5y minus y is 4y. I find that my value of y is 11, and now I'm going to plug this value into one of the 2 equations. I chose the second equation. It doesn't matter which equation you choose, you're going to get the same value of x. So 17 equals x plus 11. 11 is the value of y, so I replaced 11 with y. Gives me the value of x of 6. So the solution to this problem is 6, 11. That means there are 6 $1 bills and 11 $5 bills. Adding up is a total of $17 bills in all, and their values total $61. There you go. Your task now is to complete this practice portion, completing the real-world worksheet found on Moodle. Before you leave, I can't end without a joke. So my joke for you today is, why didn't the 2 4s want any dinner? Because they already ate.
Made with Doodlecast Pro.